Assalamualaikum and hi. This is the exercise for hypothesis testing. So I give you two questions for your exercise. So this is the question 1. So we can read from here the question. Body mass index BMI was collected from 14 male subjects. The researcher wants to conclude that the BMI is not 25. So I bold here. The BMI reference standard for a male is a standard deviation of 5. So this is the BMI reference standard. Okay. And at the 0.05 level of significance, use the traditional or critical value approach to test the hypothesis testing. So the table below shows the BMI scores of the male subjects. So you can see that we have 14 subjects and the BMI value for each of the subjects. So how to settle this question or how to solve these questions, as I mentioned in the class, there should be of 4 steps in order to solve these questions, right? The first step is you have to bear in mind that the first step is state the null and alternative hypothesis. Step 2, you need to calculate the test statistic. Step 3, formulate the decision rules. And step 4 is state your conclusion. So we will do this exercise one by one. So from the question, as I bold just now, you should know that when you want to state the null and hypothesis testing, you have to know the value, right? The value to state this hypothesis. So we go back to the question. We can see here that the researcher wants to conclude that the BMI is not 25. So it means that it is the alternative hypothesis testing where you want to state that the claim, when you want to claim, when it said claiming is actually reflect to the alternative hypothesis testing. So the researcher claimed that the BMI is not 25. So you must state here that the alternative hypothesis is mu is not equal to 25. Alright? So it means that the null hypothesis should be equal to 25. Right? Okay, so we go to the step 2. Step 2 is calculate the test statistic. So when we want to calculate the test statistic, there's a note I put here for you to understand. Right? Here is stated that the standard deviation that we are to use for this problem is did not come from the sample. So therefore, this will be Z test, not a T test. Okay, since you can reflect here, the standard deviation is from the populations, where it's referred to the BMI reference standards for a male. Right? So it means it reflects to the population instead of the samples. So if it doesn't mention the samples, right? So you have to read carefully whether it give you the value or you have to find from the data from the table. So if there's if the value is not stated, so you have to calculate from the table. Right? For these examples given to you, the standard reference, the reference standard for the male is 25, means that this is a Z test where the standard deviation is come from the population. So this is the formula that we can use, right? Z is equal to sample mean minus population mean divide by population standard deviation per total sample size, right? So for this problem, we go back to the basis, or from the question we can find the value of each of it, right? What we can find is the standard deviations. The standard deviation is equal to 5. The number or total sample size is 14, and the sample mean is 27.43. Alright. So how to find the sample mean of the 27.43? You have to take the average of all of the data and divide by 14. Right, so you have to add all of this from 29, 23, 27, 28, 29, 33, 23, 29, 25, 28, 30, 27, 26, 27. You sum up and you divide by 14, you will get the value of the sample mean is 27.43. So now we have to substitute the value in order to find the Z, in order to find the dash statistic. Okay, so we divide it. So from here that we'll get 27. Here is, we have to calculate by ourselves. 7.43 minus the population mean is 25, and you'll get, you are given already the standard deviation of the population is 5, and the total sample size is 14. So you calculate and you will get the 2.43, right? For the for this, and okay, so and the lower part is 1.34. So it gives you equal to 1.8. So this is the value of your dash statistic, right? So now you get the value of the statistic, and how to formulate the decision rule. So you have to know which method you want to use in order to decide, right? To make a decision whether you will have to reject or not reject the null hypothesis, right? Or you want to accept the claim in alternative hypothesis. So this is the question we want you to solve this with a traditional or critical value approach. So we have to use the traditional method. Here is we have mentioned that the significant value are given with the alpha equal to 0.05. So this case, whether you want to clarify whether two tail or one tail, you have to check back with the question or your null hypothesis. So the null and the alternative not equal and equal means that it's a both. You want to see in a two directional. You want to see not two directional. It's mean you want to see directional. No, sorry, it's a non-directional. So non-directional means you don't bother to see the greater or the lesser, you just want to see it's not equal, right? So it's a two-tail, it's a non-directional. So when your symbol is not equal, so it's reflect to a two-tail means non-directional hypothesis testing. So we have to divide the significant value into two, okay, because you want to see both sides. Okay, so you set up the rejection region. You have to draw the Z curve, right, for you to understand. So and confidence to whether you want to reject or not, and you shade the most extreme 2.5. This is when you divide, you will get the 0.025. That means 2.5% of both tails. So you can draw it, and So you need to find the Z critical value. You already get the Z test statistic. Now you have to find the Z critical value. So you have to go to the appendix and find where the P is equal to 0.25, and you will find the critical value is actually plus minus 1.96. So you can draw here and put the value of it for each of the region, the negative region and the positive region. The negative, of course, negative of 1.96, and the positive is 1.96, right? So um, finish with the Z value. So Z value, and you need to state your decision. So when you want to state decisions, you have to understand that this is the traditional method. So the traditional method is you see the critical value, alright? You find the critical value and you compare with the test statistic value. So since these two tails, so you have to make sure if the Z test statistic is less or equal to Z critical value, or the Z critical value Z test statistic is more or equal to Z critical value, you reject the H naught. So in this case, we find that where the test statistic we don't know falls or does not fall into the rejection region. So you get the value of here is 1.8 for the test statistic. So this is the Z critical value. So here it means that is actually less, right? Less of the critical value, right? So it's between it. So if you see from the rejection regions, you are in here, you are somewhere here. So we're somewhere here. So it's in the area of non-rejection region. So it means that it does not fall, right, into the rejection region. So we do not reject the null hypothesis, and it means that there is not enough evidence that the population is different from 25, so we could conclude that the population BMI is actually equal to 25. So this is the answer of your question. With that, good luck for you to do this exercise.